All right, now we're going to talk about finding the domain of the functions. You should have either this slide in front of you or have read it and kind of know what we're talking about here. For domain, we have to know about our restrictions. All the ones in blue are the ones that do not have any restrictions. So those domains are all real numbers. We have two types that have restrictions here. We have radicals and rationals. We're going to focus on both of those today. So to start us out, know your function families. This one's a quadratic. So domain is all real numbers. There's the symbol for all real numbers. That's one way you can write it. All real numbers in interval notation can also be expressed as this, -infinity to infinity. Pick one of those ways. Don't write both. You can if you want. Pick one, stick with it. All right. Next one. Radicals, square root more specifically. We have restrictions. If you look at that last slide, you can see how we go about it. So we have g of y equals y minus 10. I cannot end up with a radical underneath, or sorry, I can't end up with a negative underneath the radical. So I need to make sure what's underneath the radical is greater than or equal to 0. You solve the little mini inequality. Very simple in this case. Y has got to be greater than or equal to 10. That is one way to write your domain. That's the one I suggest. You can write it in interval notation if you want. That'd be 10 to infinity. There are certain ones that I suggest. Domain, in this case, I suggest the top one. I suggest the top one again in the last problem. These are just easier ways to write it. Next one. We have a rational equation, fractions. We can't have 0 on the bottom. So you need to figure out what makes each part 0 or each bottom 0. What makes that one 0? Well, x would equal 0. So in other words, x cannot equal 0. Second one, x cannot equal +7. All right, so here's how we write our domains. My suggestion is you can write all real numbers except x cannot equal 0 or 7. That to me is the easiest way to go about it. Now, there's other ways. Honestly, I'm not even going to show a second way for that one. I think that's the best way to write it with fractions. All right. Tell me it can be anything, any number possible except those two. All right. That's going to be the easiest way to write that. Let's combine some ideas for these last two. So I have a fraction and I have a radical. So I have two separate restrictions. Let's check this out. So I need to check out my restriction up top. My restriction up top is this. It's got to be greater than or equal to 0 in there. So I solve that little mini inequality, and it's greater than or equal to -4. We'll hold on to that idea. We figure out what's going to make the bottom 0. So we have to factor it. Maybe you don't need to factor this one. You can do that in your head, and that's okay. So x cannot equal 0, or sorry, 3 or -3. Now, we have to look at those two restrictions combined. This first one covers more ground. We need to look at our restrictions on the bottom and see if they fall within that window. Are 3 and -3 greater than -4? Yes, they are. So what we have to do is combine those two together. X can be greater than or equal to -4, but x cannot be plus or minus 3. That's the easiest way to write that one. We can get pretty detailed with anything else. I would just write it like that. Next one, same deal. But if you look at your slides, we notice there's no restriction for a cube root. It's all real numbers. There's no possible way. There's no real number that we can make this 0. It's a square plus a 2. So a square is always positive, and we're adding to it. So this is all real numbers too. It's one of the tricky ones. Just watch yourself. Both parts have all real numbers as a restriction. So there are two ways to write it. Again, I lean towards one way versus another. And there's our domains for many function families.